All right. 3-4, trig functions of special angles. In what quadrant did we say we're dealing with today? 1. We'll deal with 2, 3, and 4 tomorrow. All right. This is review not only from Math 3, but also from Math 2. So, I'm going to fix that one. I don't like the way that middle one came out. All right. So we're going to deal with our special triangles, our 30, 60, 90. Do you guys remember those? 45, 45, 90. Okay, so 30, 90, 60. We'll do that one first. Okay, does anybody remember like the A root 3, 2A business, which one was which, hypotenuse, anything, the short leg? This here we're going to call the long leg. And this I'm going to call the short leg. And of course this is the hypotenuse. Does anybody remember any of the letters, where the numbers and letters and where they went? 2A was for the what? Okay, 2A. The smaller leg would have been A or A root 3? A. And the longer leg would be A root 3. All right. 60, 30, 90. Now, is there any difference between this 30, 60, 90 and this 30, 60, 90? The only difference is the way it's positioned. Now kids are like, well, why do we have to draw it again? I'm drawing it again only so that when we get to our unit circle we can see it. When I flip it around to 60 being in the bottom left corner, this now becomes my short side. Do you agree? And this side here is my long side. Is the hypotenuse still 2A? Yes. Yes, it is. All right. So here the short side was A, so this short side will also be what? A. And the long side will turn out to be what? A root 3. All right, questions so far? And what's this last one going to be? 45, 45, 90. All right, does anybody remember the numbers and letters that go here? AA for these two because they are the same, and the hypotenuse was what? A root 2 is correct. All right. Questions on any one of these? Okay, what we're going to do next is we're going to try to get these to have a unit 1 radius here. We're going to put these in the unit circle like I showed you earlier. But a unit circle has this radius here always equaling what? 1. So do you agree the radius is equivalent to our hypotenuse? Yes? So we want to get each hypotenuse here equal to 1. So we're going to do some math. Let me redraw this one first. Okay, so let's do some thinking. We're going to do some math in our head, and we will write it down as well. What would A have to equal in order to get this hypotenuse to 1? A half. Does everyone agree that A would have to equal a half? Yes, because 2 times 1/2 is what? 1. Now how, if you couldn't do that in your head, you would do this. 2a equals, we want it to equal 1, and what do we divide both sides by? 2, and do we get a is 1/2? Yes or no? All right, if a is 1/2, then that goes here on the short side. So this is 1. What am I going to put here on the short side? 1/2. And 1/2 times root 3 would be root 3 over 2. Ring a bell? You guys remember this? Mm-hmm. Okay. All right. Next one we're going to do is another one just like the one we just did, but with their angles flipped around. Okay, 60, 30, 90. Again, if I want the hypotenuse to be 1, I put the 1 here. It's going to be the same work. 2a equals 1. Divide, and a equals 1/2. So where do I put the 1/2 here? Across the 30 or across the 60? Across the 60 would be here on the long side. Across the 30? Is it across the 30 here, 1/2, and across the 30 here, 1/2? Does that make sense? All right, so across the 60 here is root 3 over 2. So what will be across the 60 here? Root 3 over 2. And again, it should make sense. A is 1/2. 1/2 times root 3 is root 3 over 2. Any questions on any of this before I move on to the 45? Yes? How did I get the root 3 over 2? Right here on both of these, I'm just going to show it once since they are the same. A root 3, if A is 1/2, I'm just going to plug it in for A, 1/2 times root 3 over 1. A is 1/2. Let me get that in screen, I apologize. A is 1/2, we figured that out earlier. So 1/2 times root 3 is root 3 over 2. Or you can write it as 1/2 root 3 if you choose. But I will usually typically write it as root 3 over 2. Got it? And again, that is the same as 1/2 root 3. Okay, 45, 45. Okay, so with this one, again, do it in your head or do it on the side. What does A need to be so that it will equal, the hypotenuse will equal 1? What does A have to be in order for the hypotenuse to equal 1? What is it? Root 2 over 2. Did you guys use root 2 over 2 or 1 over root 2 last year? You guys did? All right, I'm going to divide. And I get 1 over root 2. Is 1 over root 2 equivalent to root 2 over 2? Yes, I'm going to leave it as 1 over root 2. A equals 1 over root 2. All right, so if this is, I want this here to be 1, and A is 1 over root 2. 1 over root 2 times root 2 does indeed become 1, yes or no? And these two A's are the same, and we just figured out they're 1 over root 2. So that's where this is coming from here. 1 over root 2, 1 over root 2. Any questions on how we came up with these new side lengths and the hypotenuse coming out to be 1? Yes? What is that?
Why are we trying to equal it to 1?
Good question. Her question was why are we even bothering trying to get this to 1? Does anybody have an answer for that? Right, because we're trying to make it into a unit circle. We want to get these sides here to the unit circle, and the way to get that is if the radius is 1. All right? Okay, so that's why. That's why we're trying to get it to a radius of 1. So let's fill in our unit circle. Now, are we dealing with all 4 quadrants? No. We're dealing with only quadrant 1. Okay, I know I jumped to quadrant 2, but this is the only quadrant we're dealing with. Okay, so we want to come up with this stuff here. I'm going to start with the 30, and I'm going to use red. Now, you're going to approximate where 30 should be. Of course, 30 degrees is not going to be way up here, but somewhere closer to the x-axis. So that right there would be at 30 degrees. Does that make sense? All right. So I'm going to put the point here on my circle and drop my line down and make a right triangle. Does everybody see that? Okay. If the hypotenuse is 1, and it has to be 1 because this is a unit circle, and in a unit circle, we said it in our notes a few days back, the radius is 1. And this is the radius of the circle. Do you see that? All right, what is this long side going to equal? I'm sorry, this one here. What is this long side going to equal if the radius is 1? Root 3 over 2. And what is this side going to equal here? 1/2. Do you see that? Okay, now what I'm going to do is label that as an ordered pair. X comma y, so how far to the right and how far up? What do I put here in my X spot? How far to the right and how far up? Root 3 over 2, bless you, comma 1 over root 2. Okay, does this kind of ring a bell from last year's unit circle that you guys filled in? Yes? Did you guys do all of this, or they just gave you the numbers?
We had to fill it.
You had to figure all this out? Yes.
How'd you get 1 over root 2 isn't it 1/2?
It's 1 over root 2. This right here, I just didn't write right. Oh, here it is. Thank you, thank you. Going too fast. Good job, you guys. Okay. All right, did anybody else catch that and wasn't sure what the heck I was writing? Sorry. All right. Okay, next one I will put in this turquoise bluish color. And that should not be my next one. I will leave it in that color, but which one should be my next color? 45. So I'm going to jump over to the 45, because if I am going in order, it goes 30, 45, 60. All right. Okay, it's going to get really messy if I put angles in every single one, but can you see that red one is 30 and this green one here would be 60? Do you see that? Okay, I'm sorry, 45. When I'm dealing with the 45, what is my x value going to be and what is my y value going to be? Good job. 1 over root 2 and 1 over root 2. Okay, so that angle's 30. This bigger angle here is 45, which means x value is 1 over root 2 and y value is 1 over root 2. All right, now coming back to the 60. What's the only difference between the 30 and the 60? The 30, you have the long side for your x and the short side for your y, where with the 60, you have the short side for your x and the long side for your y. Do you see that? Yes? So, yes, that's exactly what you do. You just flip them. So this is the x and this is the y. So what is it going to be? 1/2 comma root 3 over 2. All right. Tomorrow, tomorrow block day, we'll get the actual big unit circle that you guys got last year, right? You did that and filled it all in. We'll be doing that tomorrow. Okay, any questions on how we filled in quadrant 1? Okay. We are going to find sine of 30, cosine of 30, and tangent of 30. All right, remembering from years past and what we've been doing these last few days, sine is what over hypotenuse? Opposite. So I'm on the 30, so I'm on the this one here, it's easier to see. Opposite over hypotenuse becomes what? 1/2 over 1, which is just 1/2. Do you have to write 1/2 over 1? No, it's better if you don't. Okay, cosine of 30. Cosine is opposite or adjacent? Adjacent. So adjacent of 30 would be root 3 over 2 over, which is just root 3 over 2. And tangent of 30, I'm going to do that work over here because it does get a little messy and I don't have enough room down there. Tangent of 30, what is tangent? Opposite over adjacent or adjacent over opposite? So that gives me what over what? 1/2 over opposite over adjacent would be 1/2 over what? Root 3 over 2. All right, so that's the same thing as using this red circle here. You can, or red triangle. 1/2 over root 3 over 2. When you're dividing fractions, you multiply by the reciprocal, so it's 1/2 times what? 2 over root 3. Is anything going to reduce there? The 2. So I'm left with root 3 or 1 over root 3? All right, 1 over root 3. If you want to put a little note here so you know where that work came from, it's there. That's how we got 1 over root 3. Okay, what are we going to do next? Sine, cosine, tangent of what? 60. Sine, cosine, tangent of, do you guys want to do 60 or 45 first? 45. Okay, it's here, which is the same as this one over here. Sine is opposite over hypotenuse. What is that going to give me? 1 over root 2. Cosine is adjacent over hypotenuse. What is that going to give me? 1 over root 2. And tangent is opposite over adjacent. Without doing any work, can anybody tell me what 1 over root 2 divided by 1 over root 2 is going to become? 1. Do we need to show work for that, or are you guys good? We're good. 1 over root 2 divided by 1 over root 2. If they're exactly the same, it's going to reduce to 1. Are we good? Okay. Sine, cosine, and tangent of what? 60. Did you guys work on memorizing these last year? Yes. Did you guys still have them memorized, any of you?
Isn't it size always y?
Good. We're going to write that down right now. So you guys are ahead of me. Let's just go ahead and fill this in really quick. Sine of 60 is root 3 over 2 over 1. So what do we get? And then cosine of 60 is 1/2 over 1, which is 1/2. I'm going to do tangent of 60 here. Tangent of 60 is what over what? Root 3 over 2 divided by what? Which is root 3 over 2 times 1/2 or 2 over 1? The 2's reduced, and what are we left with? Root 3. Okay, a few things you should recognize. Sine of 30 and cosine of 60, do they end up being the same? Yes? Sine of 30, I'm sorry, cosine of 30 and sine of 60, do those end up being the same? Tangent of 30 and tangent of 60 are what? Not opposites. Reciprocals, 1 over root 3 over 1. And is sine 45, cosine 45, and tan 45 pretty easy to remember? 1 over root 2, 1 over root 2, 1. All right, so we'll work on memorizing these, memorizing the whole unit circle eventually. Now, tell me what you said a second ago.
That sine is the y and cosine is x.
Do you guys remember that from last year? All right, so usually I would explain and but you guys have seen this before. So sine here's my red triangle. She's saying that sine of 30, sine is the y value, where cosine is the x value. Let's check it over here on the bigger triangle. Sine is the y value and cosine is the x value. Does that work? All right. Okay, so let's write that down over here. All right, so what would you say? Cosine of theta, sine of theta, and tangent of theta. Cosine of theta is what over what? I'm sorry, what letter? X. Sine of theta is what letter? And does anybody remember what tangent is? Y over X. Does anybody need me to explain that? Y over X. It's coming from right here. Tangent of 30 is 1/2 over root 3 over 2, y over x, or y over x. Do you see that? Same thing here with the blue one. Root 3 over 1/2. We did down here, so y over x. Y over x. All right. Questions on that before we move on? Okay, now usually I spend some time converting, but it seems like a lot of you guys remember 30 degrees, 60 degrees, 45 degrees, what they are in radians. Do you guys remember? 30 is pi over 6, 60 is pi over 3, and 45 is pi over 4. Okay, would you guys like me to show you that using the conversion factor that we did the other day? Here, I'll show you at least one of them. Let's pick the 45. If I'm trying to change 45 degrees to radians, these are all radians. Am I going to have radians in the numerator or radians in the denominator? So it'll be pi radians over what? 180. And does 45 and 180 reduce? 45 becomes 1, and 180 degrees becomes what? 4. So I have pi over 4 radians. Make sense? And if you did this exact same thing with 30 and with 60, would you get pi over 6 and pi over 3? Okay. Questions before we move on? All right. Fill in the blanks. Function theta in degrees, theta in radians, and the function value. All right. Our first function will be sine, and I'm going to give you 30 degrees. And that's all I'm giving you. Do you have enough information to figure out what 30 degrees is in radians, or you have it in your head already? What would I put here? Pi over 3 or pi over 6? Pi over what? 6. All right. Sine of 30, you either have memorized or you look back at your chart. What is sine of 30? 1/2. So that's the function value, and we're done with this particular problem. Any questions? Let's try another one. I'm going to give you secant and 45 degrees. And what would you fill in here? 45 degrees is equivalent to what? What is it? Pi over 4. Secant is the reciprocal of what? Cosine. Do you guys remember with the letter swap? Okay, so find cosine of 45 and then take the reciprocal. What's cosine of 45? 1 over root 2. So you reciprocal it, and what do you get? Root 2 would be that number there. Any questions? Okay, next one, cotangent. And I'm going to give you the answer down here. The function value is root 3 over 3. And you have to figure out what degree would that be. Okay, you ready? I'm going to look over here. First off, cotangent's the reciprocal of what? Tangent. So even if I flip this root 3 over 3 and I flip it to 3 over root 3, do I have any 3 over root 3 anywhere here? No. So let's go back to this, and can anybody tell me what was done here? It was rationalized. Now, I don't rationalize, and I don't want you guys rationalizing, so can we unrationalize to figure what it was to begin with? This doesn't happen very often, but there's occasional math problems in the textbook that have been rationalized like this. So if I did root 3 over 3, I would unrationalize it the same way I would rationalize. So I multiply top and bottom by what? And what's root 3 times root 3? Over 3 root 3. And what does that reduce to? 1 over root 3. Okay, so now it's easier to look at. Cotangent is 1 over root 3. Again, cotangent's the reciprocal of tangent. So look over here, and when you're looking for tangent, are you looking for 1 over root 3 or root 3 over 1? Root 3 over 1. Why? Because it's the reciprocal. So is that 60 or 30? 60. Do you see that? Now kids will say, but it's 1 over root 3. Yes, it's 1 over root 3, but cotangent is the reciprocal. So the reciprocal of 1 over root 3 is root 3, so the degree is 60. Which is what? Pi over 3. Now, makes sense? More explaining. Hand up if we have any questions. No hands up, so I'm assuming everybody got it? Okay. Evaluate. This next piece, kids tend to struggle with a lot on the test, but I'm hoping you guys, since you're coming with a little more experience, will do better. Evaluate 0 degrees is less than or equal to x, which is less than or equal to 90 degrees. Can anybody tell me what quadrant I'm dealing with if I'm between 0 degrees and 90 degrees? Quadrant 1. So this is pretty much just saying restrict yourself to quadrant 1. And is that all we've really been doing anyway? Yeah, so it makes sense. We're only working with quadrant 1. Okay. Number 1. Sine of theta equals root 3 over 2. All right, so I'm pretty much giving you the answer, and I want you to tell me what theta is. So you're trying to evaluate, you're trying to find, and instead of x there, I should have put theta, or change that theta to x. I'm just going to change this one to theta. All right, what did you say the answer is? Let's check. Is sine of 60 root 3 over 2? Yes or no? Okay, so what's your answer here? 60 degrees. And if you wanted to put it as a radian instead, what would you put? Pi over 3. I'm not sure what it asks for in the book. If it asks for both, you write both. If it just leaves it open, you can put 60 degrees or pi over 3. If it's specific for radians, then you put pi over 3. Specific for degrees, you put 60. Make sense? Okay, number 2. Tan of theta equals 1. What is theta equal? Say it again. 45, because tan of 45 is 1. So you could put 45 degrees or pi over 4. And technically these are what theta would equal. I'm writing both. Do you have to write both when you're doing homework? Only if it asks. If it says give it in both forms, then you have to. Okay, number 3. Secant is 2 over root 3. Okay, secant's the reciprocal of what? Cosine. So in your head, what are you thinking of? When is cosine what? Root 3, and I did forget my theta there. You're asking yourself, cosine of what angle is root 3 over 2? That's what you're thinking of in your head. So go back to your chart. Cosine of what angle is root 3 over 2? What is it? 30. So 30 degrees would be your...
Just put in my notebook. That's my tool. Got it.
Okay. You need to get that fixed. Okay, so I'm sorry. What was the answer? 30 degrees. Or pi over 6. Got it? Make sense? Yes or no?